So in this video, we are going to talk about different execution types. Execution here means executing processes on your computers. So the first type is multiprogramming and multitasking. In this case, we're assuming that there is only one processor to work with. So since you have only one processor, but there could be so many different things to do, especially when you want to run multiple programs at the same time. At least to create that illusion, you need to use the same processor to run multiple processes and make them take turns in terms of using that single processor. So you will let one processor occupy that processor split second, and then you'll move on to the next process and so on. So when we do something like this on mainframe computers, which is very outdated and old, we call it multiprocessing. So on a mainframe computer, these are the computers that took up an entire room and enormous in size, sort of a legacy type of system that's not used anymore too much. The next situation is more familiar to us, which is multitasking, where you try to run multiple processes on your own personal computer. So again, if you have only one CPU, then the only way to have multiple programs running at the same time is by taking turns. So usually on PCs, we do this, and it's called multitasking. And the things are changing a little bit because here now we're talking about processors with multi-cores and so on. So we don't really have to worry about this too much because you're not limited to only one processor anymore. So the next type is multiprocessing. And in this scenario, there are multiple processors involved completing the execution of a single application instead of multiple applications. There are mainly two different types of multiprocessing. One of them is called symmetric multiprocessing, or SMP. And in this case, SMP shares a common operating system, data bus, and memory resource to process the execution of an application. Another type is called massively parallel processing, or MPP, and this of course involves also multiple processors, but in this case each processor has its own OS, databus, and memory resource. So they're independent, which is why you need another program that somehow controls all these individual operating systems to get the work done. So then how are SMP and MPP, these two different approaches, are being used? So in case of SMP, it is mainly used for simple operations but requiring high speed. And in the case of MP, it is mainly used for a large, complex, and computationally challenging or intensive tasks. So those are the different applications of these two different approaches. Finally, the last type or execution type is called multithreading. In this case, we're not dealing with multiple processes, but we're talking about only one process. And multithreading really deals with multiple concurrent tasks within a single process. So remember that we're talking about only one single process, but then we try to even divide that process into multiple tasks and then try to do things in a concurrent fashion by taking turns again. So these divided tasks actually is controlled by something called a thread, and thread is simply a self-contained sequence of instructions, so they're independent from, for example, other threads within the same process. So if you have multiple threads of control in the same process, they're all executing at the same time. I mean, not exactly at the same time, but they're actually taking turns. So they look like they're executing at the same time or in parallel. So basically what's going on is they're just switching between these different threads within the same process. So then what's the difference when we're talking about switching between threads versus switching between processes? The main difference is when you're switching between threads, it's much more efficient because, I mean, the amount of work that needs to be done to accomplish something like that is much smaller. So that's why it's much more efficient with less baggage. So in terms of instructions, we're talking about dozens of instructions versus thousands of instructions within a single process versus between multiple processes.